Hi everyone. For today's video, we're going to continue the Foundation Mastery Method series, and today we're talking about differential equations. So let's take this example. Find the general solution of the differential equation d2y dx2 minus 10 dy dx plus 25y equals 20 e to the 5x. So to start off, let's assume y equals mx is a solution of the homogeneous part. So the homogeneous part is essentially the left-hand side, where we equate the left-hand side to 0. So we assume that this is equal to 0. And so if we assume that y equals e to the mx, the first derivative using chain rule is m e to the mx. And then our second derivative is m squared e to the mx, right? Now we can substitute this into our original equation, and we notice that each term has e to the mx, which equates to 0. So that term gets cancelled out, and we're left with m squared minus 10m plus 25 equals 0. When we simplify this, we get m equals 5 and 5, which means we have repeated roots. Now, the complementary solution of the homogeneous part is given by c1 e to the 5x plus c2x e to the 5x. Now, the reason for adding this x to the second term is so that we can distinguish between the terms. So c1 and c2 are arbitrary constants, and we don't want them to get diffused into our terms. So we add this x as a kind of barrier to separate it. Now for the particular solution, we assume that the particular solution is equal to ax squared e to the 5x. Now, here once again we've added the term x squared because the complementary solution has an x term, and so in order to distinguish it, we add x squared here. So once we have our particular solution, we find the first derivative using a combination of the chain and product rule. This is what we're left with. We then proceed to find the second derivative as well. And now we plug all of these into our original equation, and we're left with this long equation, but we notice that each term contains e to the 5x. And so that term can be factored out, and once we simplify this equation, we're left with 2a equals 20, which implies a equals 10. Therefore, the general solution of this differential equation is the sum of the complementary as well as the particular equation. And our final answer will be c1 e to the 5x plus c2x e to the 5x plus 10x squared e to the 5x.
Alright, now we are taking another example, y equals a t to the n e to the 3t, and we want to consider this one as a particular solution of the differential equation y triple prime minus 9y double prime plus 27y prime minus 27y equals 10 e to the 3t. So this is a third order differential equation. We need to find smallest possible value of n so that y equals a t to the n e to the 3t is a particular solution. Assume y equals e to the mt is the solution of the homogeneous part, meaning is the left side we have equal to 0. We just ignore the constant coefficient right now for the complementary solution. So now we need to find all the derivatives, first derivative, second and third derivative. So in this case, we get first derivative is m e to the mt, second derivative is m squared e to the mt, and the third derivative is m to the 3 e to the mt. Now we'll be plugging all these values, and we get the characteristic left side, which is m to the 3 minus 9m squared plus 27m minus 27, because e to the mt you can factor out and drop that one because right hand side is 0. And then we actually get m to the 3 minus 9m squared plus 27m minus 27 as m minus 3 to the 3. If you try to do the factor of this left side polynomial, you will get it. Now this solution is giving us m equals 3, 3 and 3. So 3 is repeated 3 times. So then the complementary solution now we can write as c1 e to the 3t, and then c2 we must keep another t e to the 3t, otherwise c1, c2 will be absorbed as a new constant. And then the third one will be C3 t squared e to the 3t. So now when you're looking for particular solution, we must have yp equals a t to the 3 e to the 3t, because we have t squared here in the complementary solution. So we take the further next step, a t to the 3 e to the 3t. The smallest possible value of n is then 3 in this case. Thank you.